Okay, yeah, like I said earlier this morning, around I think few minutes after 2 or thereabouts, we are solving these questions. Someone sent it to me from the University of Abuja. These are assignments. Not only this one, so the person has brought more assignments again, over 20. So what I will do is I will just solve few of these. Then we are able to solve this, and this in the morning, and I promise to be live this afternoon. And I'm here. So I'm going to solve out of 1, 2, 3, 4, 5. Few here. Then I'll go ahead to solve the one we are sent again. So please, I want you to like, comment, and share. Is that clear? And I'll be very grateful. You don't need to pay me. I'll be very grateful. Okay, so let's look at it together. Okay. Yeah. So I need to clean this. I need to clean all this. I want to consider this one. Okay. Let me clean all this. Yeah. Sorry. Okay. Okay. That's integral what? Integral 0 to 1 sec open bracket 3x dx, right? True or false? So I want to look at it together. Amen? Okay? So if you have any question, you ask. Okay. So what we need to do here is for us to write solution. Integral 0 to 1 sec 3x dx is equals to, when you integrate sec, you are supposed to have tan x plus sec x, right? So it's the constant. But these are what? Definite integrals, so the constant will not be needed. So if you integrate this, you are going to have 1 all over 3 dot, in open brackets tan 3x plus sec 3x. Then at 0 to what? 1, because these are definite integral. Do you agree with me? You agree with me, right? Okay. So that is how we are going to integrate trig functions. So if you agree with me, yeah. So this implies that we have to substitute the lower limit from the upper limit. You agree with me? So here we now 1 all over 3 times in open brackets tan 3 1. Because anywhere you see x, you write 1. Then plus sec 3 open brackets 1. Then okay, since this 1 all over 3 is common, let's do it this way. Then minus in the same thing applicable times 0 3 open bracket 0 plus sec 3 open bracket 0 close bracket. Yeah, this is how you are going to evaluate this limit. But mind you, all of this will be 0, true or false? Because times 0 times 3, 0 times 0. 0 times 3, 0, sec 0. So it will be 0. So this implies that we have to, yeah. So this implies that we'll be left with this. So we can leave it in this form, 1 all over 3 in open brackets. Sorry, this is bracket. 3 times 1 and 3. 3 times 1 sec 3 close brackets. Mind you, you are not going to have plus a constant. Why? Because this is not an indefinite integral. So this one you evaluate to obtain value, and this is the value you have gotten. So this is how you are going to consider this integral. Do you have any question, please? Any question? Do you have any question? Yes or no? No question? So it means we can proceed, right? Okay. Let's proceed further to consider an example. Another example. Okay, I can clean, right? Let me clean it up. Okay. Okay, let's look at this. It said evaluate evaluate integral 0 to 1 tan inverse 3x. The x is simple as ABC. It is not difficult. Okay, so we write solution integral 0 to 1 tan inverse of 3x dx. Now these are three functions. So you have to make use of the formula. So we know that if we integrate, okay, you know, tan inverse, note that I want us to know something first. Note that tan inverse of x is the same thing as what? 1 all over tan x. True or false? Do you agree with me? True or false? It's true, right? Okay, so what if now we now have tan inverse of 3x? So it means this is the same as 1 all over tan 3x. So if you agree with me, it means we can transform this integral in this form. Integral 0 to 1, right? 0 to 1, then 1 all over tan 3x dx. Did I commit any crime? No. True or false? Yeah. Okay. So if you agree with me, it means we can now integrate this. So when we integrate this, we are going to have 1 all over 3 times n sine 3x at, okay, let's just do it this way, at 0 to what? True or false? Yeah. So subtract the lower limit from the upper limit. So this is what you are going to do. Implies that we are going to have 1 all over let 1 all over 3 be constant. Open bracket sine 3 times 1. Then let's into the constant minus sine 3 open bracket 0. Yeah. You agree with me? So lower, we just subtract lower limit from upper limit. So far so good. This is equals to 1 all over 3 open bracket in 3 times 1 sine 3 minus 3 times 0 sine 0, right? So what is sine 0? Is 0, right? So far so good. 1 all over 3 in sine 3. Then this is what we are supposed to arrive at. Look at it. This is what you are supposed to arrive at. So do you have any question? Please ask. Drop it in the comment section. Yeah, Mr. Okafo, fine. Good afternoon. You are welcome. Okay, no question. So let's proceed. Let's proceed to consider some examples. Okay. I know there are some problems you will solve. Can I clean? I want to clean. Wow. We have some good questions here. Okay. Let's proceed to consider. One of the questions says evaluate 4x squared exponential x raised to the power of 3 dx. So let's look at it together. Write solution. Integral 4x raised to the power 2 exponential x raised to the power 3 dx. So when you come across questions of this form, though it will take us time, what will first come into your mind is for us to use what is called by parts, integration by parts. So we write using by parts, right? And by parts, the formula is integral u dv equals to uv minus integral v du. So if I were you, let u be equals to exponential 3x and the v be equals to 4x squared dx. So let's do it together. Amen. So we now say let u be equals to exponential x raised to the power of 3 and the v be equals to 4x squared dx. Do you agree with me up to this point? You agree with me, right? Okay. So if you agree with me, it means inside this formula, we have our ordinary u and v. We have gotten our ordinary u as this, but we don't have our ordinary v and the u. So how can we do to obtain these two? Is by differentiating this with respect to x, integrating this with respect to what? X. So if we differentiate this, our du all over dx, we are going to have 3x squared exponential x raised to the power 3. Then if we integrate this, we are going to have v equals to 4x raised to the power of what? 3 all over 3, true or false? So we can now substitute into the so this implies that our integral 4x squared exponential x raised to the power 3 now be equals to, what is our ordinary u? Our ordinary u is this, and what is our ordinary v is this, true or false? So let us first write ordinary v, 4x cubed all over 3 ordinary u times exponential x raised to the power 3. And what is here? Minus integral v, our ordinary v is this. Sorry. Yeah. Okay, I'm coming. We are supposed to have our du. Yeah. We're supposed to obtain our du. Here, let's do it together. When you have du all over the x equals to 3x squared exponential x raised to the power 3. It means to obtain our du, we cross multiply, right? So our du will now be equals to 3x squared exponential x raised to the power of 3 times the x, true or false? So here, our du is this, then v, ordinary v is this. So let's first write this. So 4x raised to the power 3 all over 3 times du is this, right? You agree with me, right? So 3x raised to the power of 2 exponential x raised to the power of 3 dx. Okay. Yeah. So you don't need a prophet to tell you. So we can easily, this and this will cancel. So this will now be equals to 4x raised to the power 3 exponential x raised to the power of 3 all over 3 minus integral 4x. Here we have x raised to the power 3 times x raised to the power 2. X raised to the power 3 times x raised to the power 2. You apply your what? Indices. So here will be x raised to the power 5, right? X raised to the power 5. Then exponential x raised to the power of 3 dx. Yeah, some of you are expecting me to write plus the constant. No, we cannot write plus the constant. Why? Because the integral still exists here until this integral vanish. That is why we can have plus the constant. Do you understand? Do you have any question, please? Any question? No question? Okay. So let's proceed further. Let us proceed further. So it means we are still going to use by parts here, this integral. We'll still make use of this formula as usual. We'll now say we indicate using by parts to obtain integral 4x raised to the power 5 exponential x raised to the power of 3 dx. So look at it here. So what we need to do here is for us to use, we can now say let u be equals to exponential x raised to the power 3, and the v is equals to 4x cubed dx. So when we differentiate the u all over the x, it's going to give us 3x squared exponential x raised to the power 3. Then on the ordinary v, if you integrate both sides, you have 4x raised to the power 6 all over 6. So this to this, that is 2, 2, 3. True or false? Okay? So I can clear here, right? So here we are going to have here we'll substitute it into this formula. So here we are going to have, then let's obtain our du. Du is supposed to be 3x squared exponential x raised to the power 3 dx. So our ordinary u is this, right? Then our ordinary v is 2x raised to the power 6 all over 3, right? So 2x raised to the power 6 all over 3 times our u is this, true or false? Exponential x raised to the power 3 minus integral that is our ordinary v is this. Ordinary v is 2x raised to the power 6 all over what? 3, right? So then our du is this, right? So here we are going to have 2x raised to the power 6 all over 3 times 3x squared exponential x raised to the power 3 dx. True or false? It's true. So mind you, this and this we cancel, and the integral will now be 2x raised to the power 6 all over 3 exponential x raised to the power of 3 minus integral 2x raised to the power of what? 8 exponential x raised to the power of 3 dx. So it means the whole this thing is here. True or false is from this integral. So we can rewrite this here. It means this is equals to 4x raised to the power 3 exponential x raised to the power 3 all over 3. Mind you, here is negative, right? So negative multiply this, here will be minus 2x raised to the power 6 all over 3 exponential what? X raised to the power 3. True or false? Huh? True or false? Then here will now be plus integral 2x raised to the power of 8 exponential x raised to the power of 3 dx. So it will continue. Is that clear? This will generate a lot of expressions of this form. So this is how it will continue. So at least I copy up to this point and stop. Yeah. At least we have done twice, isn't it? So this will continue itself. It will continue. So that is how far we can go. Yeah. Or you can continue, but it will take you time. Is that clear? Okay. So let's move further to consider the other exercises, assignments that they sent. They sent a lot of assignments. Composite functions. Composite functions. Okay. I can clean this. Not everything I'm going to solve. I want you also to stress yourself so that the equation will balance. So not all the assignments I will solve. Is that clear? Okay. Yeah. One of the assignments, we have a series of assignments here on composite functions. It says if f of x is equals to 3x plus 4, g of x is equals to 1 minus x all squared, and h of x is equals to 1 minus x. It says find f of g. F of g. Excuse me. Then minus h of f. Okay, it's simple as ABC. Is that clear? I'm going to teach you, show you. I will show you how we'll look at it together. So, this is the function f of x, and this is the function of g of x. This is the function of h of x, two of us. So, when you see these composite functions are of this form, these are composite functions. So whenever you have f of g of x, this implies that this g function must be inside the f function. That is what it means. Is that clear? Like f function, we have f of x is equals to 3x plus 4. Then g of x is equals to 1 minus x all in what? Square, right? So it means this function must be inside this Anywhere you see x, you substitute in this. So this implies that our f of x will now be, our f of g of x will now be equals to 3 open bracket open small bracket 1 minus x all in square then plus 4. That is what it means. Is that clear? So let's do it this way. Let's do it here. So here will now be, this will now be equals to what? 3 open brackets 1 minus x all in square plus what? 4. The same thing applicable. Minus h of, it means f of, the function of f must be inside h. Look at it. You substitute it anywhere you see x. So let's leave it inside the bracket like this. So our h is this, then our f is this. It means here we are going to have 1 minus open bracket 3x plus 4. True or false? True or false? Then close the bracket. Do you agree with me? You agree with me, right? Okay. So if you agree with me here, because we need to expand this bracket. You know, when you have, 1 minus x raised to the power of 2, this is the same thing as 1 minus 2x, right, plus x squared. True or false? If you open this bracket, so here this is what we are going to have. 3 open bracket 1 minus 2x plus x squared, then plus 4, then minus 1, this times this minus 3x minus 4. True or false? Okay? So this is, let's multiply this bracket. 3 minus 3 times 2x, 6x, plus 3 times x squared is 3x squared plus 1. Open this bracket using this negative sign. This times this minus 1, this times this plus 3x, this times this plus 4. Right? So we can now collect like terms. So since the highest order is 3x squared, so 3x squared, then minus 6x plus 3x, do you agree with me? Then plus 3 plus 4 plus 4 minus 1. Can you see now? So this will going to give us 3x squared. Are you following? Minus 6 plus 3x minus 3x. Then here 4 minus 1, 3. 3 plus 3, 6 plus 4, 10. So therefore, our f g of x minus h f of is equals to what? 3x squared minus 3 plus 10. This is how you are going to solve this composite function. Any question, please? Do you have any question? No question, right? So it means we can proceed to solve others. Okay? That is that. Then we have another one here, another question. Can claim this, right? Okay. Okay. Yeah. We have another question that we should find h of x squared plus. So look at this question. Excuse me. Look at this question. How can we evaluate this? How can we evaluate this? So it implies that since already we have a function here, this will be inside the here. So here will now be h f of x squared plus 1. This is equals to anyway, you see x, you write 3x plus 4. So 3x plus 4 all in what? Square. X carry square plus 1. So let us multiply out. So here will now be, this is the same thing as 3x plus 4 times 3x plus 4. True or false? So this time this we are going to have 9x squared plus 12x plus 12x plus 16. So this is 9x squared plus 24x plus 16, right? So here we are going to have 9x squared plus 24x plus 16. Mind you, we have plus 1. True or false? Then this will now be equals to 9x squared plus 24x plus 6 plus, sorry, 16 plus 1 is 17. I think this is what we are supposed to have. Then another one is to consider this g f of x is what? 3x minus 4x squared, right? Plus 6 close bracket. So this will now be f. So we substitute in f here. So here we are going to have 3 open bracket 3x plus 4. Then here is minus 4 open bracket, we write 3x plus 4. Then here is plus what? 6. Do you agree with me? Are you following? Okay. So if you are following, it means that oh, our x here is square, right? So it means this will going to give us, multiply out this 3 times 3x, 9x, plus 3 times 4, 12, minus 4. Mind you, this gives us this, 2 of us. So let's write 9x squared plus 24x plus 16, close bracket, then plus 6, right? So here is 9x plus 12 minus 4 times 9x squared is minus 36x squared. Minus 36x squared. So minus 4 times 24, 16, right? Carry 1 to this 8 is minus 96x. True or false? Minus 96x. Am I right? 24 times 4. Carry 1. 8. 9. Yeah. Right. Then 16 times 4 is 24. 64, right? Yeah. So here is minus 64. Sorry. Minus 64 plus 6. Do you agree with me? So let's collect like terms. Here minus 36. Let's subtract 2. Then here is minus 96x plus 9x minus 64 plus 12 plus 6. Are we right? Well, are we correct? So here we are going to have minus 87, right? Minus 36x squared minus 87x minus 87 plus 9. 87x plus 9 will give us that is minus 87 minus 87x minus 9x will give us this. True or false? Okay, let's consider this. Here we are going to have 18, right? 64, 18, 14, right? Minus 8, right? So 14 minus 8, 6. Here is 5. 5 minus 1, 4, right? 46. Are we right? Huh? Are we right? So here will be minus 46. Any question? Any question? No question? Okay. So far so good. Okay. Yeah. I can clean this, right? Okay. I can now clean this, right? Okay. Here the another one is here is minus, while here is plus. same as it is. So they said find find f of g of 1 minus h of g of f. So far so good. It means g of 1 is 1 plus x all is squared minus h open bracket 1 minus open bracket 1 plus x all is squared. So here we are going to have, I have 1 plus, we've done it before, 2x plus x squared minus open bracket 1 minus 1 plus 2x plus x squared close bracket. So this is 1 plus 2x plus x squared minus 1. This one times this minus 1 minus 2x minus x squared, right? So this one and this one will go. We have 1 plus 2x plus x squared and minus open bracket. This one and this one will go minus 2x minus x squared. So let us multiply out. Here we 1 plus 2x plus x raised to the power of 2 plus 2x plus x raised to the power of 2. So here is supposed to be what? 1 plus, okay, let's do it this way. This one plus this, 2x squared, 1 plus this plus 4x plus 1. This is what we are supposed to have. This is what we are supposed to have. Okay, let's consider one more. I told you I'm not going to solve everything because there are much. F of g of minus h of g of, yeah. Am I right? Okay. So g of x is what? That. So here will now be 3 open brackets x, 1 plus x all in square minus 4, then minus open bracket 1 minus open bracket what? 1 plus x all in square. So here we are going to have 3 open bracket 1 plus 2x plus x squared minus 4. 2 of us. Then here will be open bracket 1 minus 1 plus 2x plus x squared. Isn't it? So far so good. Here will be 3 plus 6x plus 3x squared minus 4 minus open bracket 1 minus 1 minus 2x minus x squared. So far so good, amen. Yeah, let's write it this way. This is 3x squared plus 6x 3 minus 4 minus 1, right? So this and this will cancel. True or false? By the time we use this to multiply, we have plus 2x plus x squared. Then this is equals to, you can add this and add this to give us 4x squared, this plus this, 8x minus 1. Yeah, so this is how you are going to evaluate this. Do you have any question? If you have any question, drop it in the comment section. Thank you for your time. Love you guys. Please don't forget to like and share. See you again. Bye.